Hi again, everybody. So here is our second and last video to kind of cover what we should have gone over in class today if we had class today. And the topic we're going to talk about here is what's called the empirical rule, aka the 68, 95, 99.7 rule. And I'll get into that in just a minute. But before I do, I want to make the comment that technically we're in 3.1 in our book now. So we're really shifting gears. In 1.6, what we did is we had some data. We're focusing on sample data, and we wanted to analyze it. In Chapter 3, what we're going to do is we're going to study one specific type of distribution. So really what I should do is kind of take a step back. Before I get into the empirical rule, I want to make the point that in Chapter 3, we're going to talk about what's called the normal distribution. And maybe you recognize that. Maybe you're like, oh yeah, I remember that when we were in the last video, we were talking about the shape of histograms. And when I have a histogram that more or less has, it's hard to draw on a computer, that shape, I guess that's good enough. I can refer to this as symmetric bell-shaped, or what we're going to end up doing when we get to chapter 3 is we're going to refer to this as approximately normal. Approximately normal because there's this distribution out there called the normal distribution that has exactly this shape. And what we're going to do in this chapter is we're going to study that distribution. And that distribution is really important because so many things in kind of a real life context end up having that shape. If you made a histogram of 1,000 randomly chosen people, track their IQ, for example. Most people would have kind of an average IQ, but there's some people that have an IQ higher than that average and some that have an IQ lower, and some who are significantly higher and some that are significantly lower. And I can answer a lot of questions about IQ if I know that IQ is approximately normally distributed. And it turns out that it is. IQ is kind of a classic example of what is. So what I want to do in this section is you're kind of told some hypothetical information. So in chapter 1, it was more concrete. You had sample data and you did stuff with this sample data. In chapter 3, it's more hypothetical. I'm going to tell you, suppose, like just trust me, that IQ is approximately normally distributed. I'll just write approximately normal kind of shorthand. So this population, if I took the IQ of the entire, I don't know, world, sure, or adults or something, and track their IQ, I know you can't do that because that population is too big, but if you did, it would follow a distribution that would kind of look like this. So I said, suppose IQ is approximately normal with a population mean of 100, which I think is true, and a population standard deviation of 15, which isn't true, but close enough. Nice round numbers I want to use. So I'm telling you that mu equals 100 and that sigma equals 15. You're not calculating sample statistics, x bar and s. You're being told these hypothetical kind of population parameters, mu and sigma. So in chapter 3, you'll typically be told that the shape is approximately normal, and you'll be told the mu and the standard deviation. The mean and the standard deviation, sorry. And if you're given all that, you can draw this picture. And the first thing you'll want to be able to do in chapter 3 is draw the picture. And so the idea is if the average IQ, if the mean is 100, then right in the middle of this distribution, I should put a 100 down here. And if the standard deviation of 15, that gives me a measure of kind of how spread out these things are. So what I want to do is I want to use this 15 to label different points on this curve. And the way we're going to do it is I want to space things out so that when I'm kind of 3 tick marks above the mean, I'm pretty close, I'm pretty far out here in the tail, close to the end of the distribution if you want, although that's a bit of a misnomer because you never really get to the end of this distribution. It goes on infinitely far, it just gets infinitely low, but don't worry about any of those technicalities. When you draw one of these things, 3 tick marks will be where you end up where you stop drawing it, or pretty close to where you stop drawing it. And 3 below maybe is just short of the end here. And these tick marks each represent one standard deviation. So if 100 is in the middle, one tick mark above 100 would be 15 above 100, aka 115. And then another tick mark above 130, and then 145. And I can count down by subtracting standard deviations. 100 minus 15 gives me 85. Minus another 15 would give me 70. Minus another 15 would give me 55. And sure, there's people with IQs above 145, so there's a little bit of room out here for IQs above 145, but not very many, which is why the height of this curve is very little. The way we're going to think about it is the area underneath the curve kind of represents everybody, the entire population. And so most people are sort of in here with an average IQ. But some are out here, and some are even further out here and further out here. It's just not very likely, which is why this height is getting lower and lower. So in chapter 3, for a lot of these problems, what you're going to end up doing is drawing this picture. And I'd like you, if I tell you that the shape's approximately normal, to be able to draw a curve kind of like this. And if I tell you mu and sigma, or if I write it out in English as mean and standard deviation, I want you to be able to count up and down by standard deviations. And just drawing the picture is important, and we'll be drawing pictures for the rest of this class, so getting comfortable with this will be really useful. But the first thing we want to do with this picture that we introduced in chapter 3 is what's called the empirical rule. And the empirical rule allows you to answer questions about this picture. So what the empirical rule says, and another name for the empirical rule is the 68, 95, 99.7 rule, is it tells me how many, so, okay, let me put it in the context of this example. 85 and 115, most people have an IQ between 85 and 115. What if I say, what do you mean most? Like what percent of people have an IQ? What percent of the population falls within that range, or this shaded area right here? How big is it? Well, I don't know. I mean, you can kind of ballpark how much area is shaded here, but you might not feel really comfortable just ballparking it. Well, the empirical rule answers that question a little bit better for us. It says that if your shape is approximately normal, and that's really important, so expect in every single empirical rule question me to say, suppose the shape is approximately normal. If you're in that case, then we expect 68% of observations to lie within one standard deviation of the mean. In other words, this shaded region right here is 68% of the total area underneath the curve. Why? Because the empirical rule says that 68% of observations lie within one standard deviation of the mean. So if I asked you a question like, I don't know, what percent, so this is building on this example from up here. So on a quiz, not this week's quiz, but on a quiz, I give you this information and I say, what percent of people have an IQ between 85 and 115? And it's worth pointing out that we're going to treat IQ as continuous and not discrete, so you don't have to worry about, does that include 85 or does it not include 80? It won't matter. They'll never, greater than or less than, greater than or equal to, none of that's going to be important. If I say what percentage of people have an IQ between 85 and 115, you recognize that 85 is one of these 15s below 100. And 115 is one of these 15s above 100. In other words, these are the endpoints for the interval that is one standard deviation above and below the mean. And my empirical rule tells me, so there's the question, my empirical rule tells me that 68% of observations, I guess I don't need the exclamation point there, that's obnoxious, fall within one standard deviation of the mean. So therefore, 68% of people have an IQ between 85 and 115. That's what you do with the empirical rule. What if it wasn't 85 and 115? What if it was 84 and 117? Won't be asked that in 3.1. With the empirical rule, these numbers, 85 and 115, have to be exactly 1, 2, or 3 standard deviations above or below the mean. Because if they're not, we can't use the empirical rule. So expect that to happen. So question 2 might be like, what percentage of people have an IQ in between, I don't know, 55 and 145? Right? Maybe you're asked that question. Well, you recognize that 55 is 3 standard deviations below the mean. And 145 is 3 standard deviations above the mean. And this third statement in the empirical rule tells me that 99.7%, damn near everybody, has an IQ between 55 and 145. Right? 99.7% of people have an IQ within 3 standard deviations of the mean. I won't draw that in this picture, but you could draw that picture. In fact, that's what happened here when I got a Google image search for empirical rule. It's telling me 68% of people lie between here and here, 95% of people lie between here and here, and 99.7 lie between here and here. They didn't know that I was talking about IQ, so they didn't know that the mean should be 100 and the standard deviation is 15. So what they did is they put a 0 in the middle, or a mu in the middle, and then 1, 2, and 3 to indicate the number, well, it didn't quite work, the number of standard deviations above or below the mean. We've heard that phrase in this class. you can think about these as z-scores. I don't want to get too complicated in here because people already get confused with the empirical rule, but this is a z-score of 2 because this observation has a z-score of 2 because this 130 is 2 standard deviations above the mean. And if you understood z-scores from 1.6, you'll see that we can kind of go back and forth between showing IQs or whatever the example is in the given problem and the z-scores associated with those things. Do the empirical rule. The empirical rule is probably the topic that gives students the most trouble in Math 243, or at least early on in Math 243. It's the hardest thing. It's the mathiest thing you've heard in this class. You're like, this doesn't seem that bad. The answer is they got to be one of these 3, right? If I memorize these 3 numbers, I'm good. Well, not quite. There's another level of abstraction that I can do. So the first kind of level of difficulty are questions 1 and 2 that you see above. But I could also ask you questions like, what percent of people, maybe I'll leave that off. I'll just put these quotes on so I don't have to keep writing it. What percent of people don't have an IQ between, I don't know, 70 and 130? Right? So a lot of people have an IQ between 70 and 130, but what percentage don't? What percentage are either above 130 or less than 70? So in my picture, I'd be talking about this red shaded region there, right? Below 70, so not between 70 and 55, but anywhere below 70, so that keeps going, or above 130. This total red shaded region, what area of the total area, what percentage of the total area under the curve is shaded in red? And you're like, well, I don't know that any of these really make sense. True, but you can use these to answer that question. Because 95% of observations lie within 2 standard deviations of the mean, that means 95% of observations are inside here, either in white or in green right now. And 100% of people are somewhere. So if 95% are not shaded in red, then 5% are shaded in red. The answer to this question would be 5%. So not only can the answers be 68, 95, or 99.7, they could also be 32%, 5%, or 0.3% if I take 100% and I subtract those numbers. So it's not enough to just be like, oh, it's one of these 3 answers. I have a 1 in 3 chance. Let me just guess. You really want to understand what's going on. And they can even get harder than this. Maybe I'm switching colors. This is the third and final level of abstraction here where these get as hard as I can make them. What if I say, what percentage of people, I'm not going to keep writing that. Sorry, I keep saying I'm not going to write it, and then I write it again, and then I erase it. It probably takes longer than if I had just written it in the first place. What percentage of people have an IQ, how about above, I don't know, 130 in my picture? And I recommend, by the way, that you always draw these pictures. On the quiz, I'm going to ask you to draw these pictures. Again, not this week's quiz, but eventually. But on the homework, you don't have to. But if you're drawing the picture, you put 100 in the middle, you count up and down by 15s. By the time you're 3 standard deviations above the mean, you're pretty far out into the tail. Similarly with 3 standard deviations below the mean. If you're curious, 1 standard deviation above and below the mean, so this point right here and this point right here, they also have significance. You don't need to know the significance for this class, but if you've ever taken a calculus class, those are what are called inflection points. And so the idea is you're skiing down this hill, right? You're not going very fast right here because the hill's not very steep. And you're not going very fast down here because the hill, again, is not very steep. You've kind of leveled off. But there's some point in here when you're going super fast as you ever go, when the hill is as steep as it ever gets. Right? And that point is what's called the inflection point, where the hill stops getting steeper and steeper and steeper and starts getting less and less and less steep. That's called the inflection point. That ends up being 1 standard deviation above or below the mean. You don't need to know that for this class. I just find it kind of interesting. Anyways, back to this problem. What percentage of people have an IQ above 130? In the picture, I'm talking about this shaded region out here. How could I possibly figure that out from my empirical rule? Well, I do know from this, this picture's getting overused. I do know that between 70 and 130, so this red shaded region right here, that I get 95% of observations, right? From 70 to 130. Wait, why 95? Because 70 and 130 are 2 standard deviations above and below the mean, respectively. So 95% of observations are in between there. This is 95% of observations. So if this is 95% of observations, that means that I have a total of 5% of observations in green and blue together, right? 95 is in red, so that means 5 is over here in green, and another 5, no, that's not true, that's a lie, sorry. 5 is in green and blue together. This and this together give me 5. But because of the symmetry of this distribution, green area is the exact same as the blue area. Right? If you look at the green, it looks the exact same as the blue over here. So together they make 5%, but they're the same amount, so they must individually each be 2.5%. So green is 2.5 and blue is 2.5. Now that I've drawn this picture, I can answer this question. What percentage of people have an IQ above 130? It's exactly 2.5%. What if I do one more on this example? What percentage of people have an IQ, I don't know, below, no, yeah, sure, I'll do 2 more. Below 85. Think about if you could answer that question. I think you can. I'm kind of short on pictures, but I guess I can draw one more, maybe down here way at the bottom. Might run into the picture above, but life goes on. Here's 100, here's 85. I won't put in the rest of the numbers, but there's one there, there's one there, one there, there, and there. How do I figure out this answer, this blue shaded region? Well, let's see. I know that 68% of observations are in here. Sorry for the poor drawing. It should be the same height on both sides. This is 68. So that means over here in blue and not shaded in white, I have a total of 32%. So in total, these are both 32%. That means 16%. I don't like that being in red. I'm going to change that color. 16% is unshaded over on this side, and 16% is shaded over on this side. This blue shaded region was my answer. So once you draw the picture, it's not too hard to figure out that this is 16%. One more, last one, I promise. Here's number 6, I guess over here because I'm low on room. This is as hard as I can make this. Percentage of people, maybe I'm going to do 2 more. Sorry, I keep lying. Have an IQ between, let's say, 85 and 130. Okay, let's draw the picture. Good place to always start with these, draw the picture. It's an ugly picture, but whatever, let it slide. There's 100, there's 115, there's 130, there's 145. Here's 85, here's 70, and here's 55. What I'm asked for is between 85 and 130. Uh-oh, that's going to be hard. If it was 85 to 115, that'd be easy. If it was 130 to 70, that would be easy. And if you see why that would be easy, that those answers would be 68 and 95% respectively, that means you're picking this up really quick, which is good because this is a concept students really struggle with. But it doesn't ask me either of those questions. It says 85 to 130. How in the world could I answer this? There's lots of ways you can answer it. Here is what I consider the easiest. That's a lie. Here is one way. Here's the way I recommend doing it. But I'm going to show you at the end of this video an even easier way to do this. It's not as useful for our class, but I don't want to hold back, and I don't want to pretend there's not an easier way when there is an easier way. 85 to 130 is shaded in blue. Note that I broke that up into 2 different regions, one that's shaded kind of dark in blue and one that's shaded kind of light in blue. If I could figure out the area from 85 to 100, and I could figure out the area from 100 to 130, then I could add those 2 together and I'd get the total shaded region. I think you can figure out those 2 areas. Think about it. See if you can do it on your own. I think you can get that this area right here is 34%. This dark blue shaded region. How do I know this dark blue shaded region is 34%? Well, from 85 to 115, I get 68% of observations. But I'm not going 85 to 115, but I am capturing exactly half of that due to the symmetry of this distribution. So this 34 right here, I got from taking 68 and dividing it by 2. Hey, you promised this wasn't a math class and we weren't going to be doing any math. Yeah, I guess I lied a little bit. The empirical rule is probably the mathiest thing we will do this entire term. If you can follow it, great. If you can't, I'm going to show you an easier way. Don't worry. But that's not the answer. It's not 34%. That's just this dark blue shaded region. To get the answer, I need to know this total shaded region from 85 to 130. Well, from 100 to 130, I claim that you get 47.5%. Where in the hell did that 47.5% come from? It came from half of this number. Why half of that number? Because that number is this shaded region, and I want half of that shaded region. I want this side of it over here. I take 95% and I cut it in half, and I get 47.5. So lightly shaded is 47.5, darkly shaded is 34. If I take 34 plus 47.5, I get 81.5%. What percentage of people have an IQ between 85 and 130? Say that's 81.5% using the empirical rule. That's hard. This and the next one are as hard as I can possibly make these. I'm going to do one more, and then I promise I'm going to end this. No, I'm not. I'm going to do one more, and then I'll stop asking you questions. I'm going to show you an easier way to do this that I don't recommend, but I just don't want to be holding out on you. What percentage of people have an IQ between, 130 and 145? Maybe I should write the word between. What are you going to do? Draw the picture. Between 130 and 145. Here's my picture. I'm a little bit low on room. Ugh, that is ugly. Try that again. It doesn't matter. It's not an art class. I will never mark off points because yours doesn't look nice. I'm going to try to make mine prettier. Put 100 in the middle because 100 is the given mean in this problem. And note that we don't have to do these with IQ. Maybe on the quiz I say, suppose the number of points that Steph Curry scores tonight has a mean of 30 and a standard deviation of 5. Put 30 in the middle and you count up and down by 5s. But in this case, I'm talking about IQ. So 100 goes in the middle, 115 at this inflection point, 130, 145 pretty far out here in the tail, 85, 70, and 55. Between 130 and 145, be in a different color, back to blue apparently, is from here to here. You want to figure out that area. If you could figure out that area, you could answer the question. How can you figure out that area? Well, there's lots of different ways. Here's my advice. Figure out the area from 100 to 130. I think you can do that. Then figure out the area from 100 to 145. I think you can do that. Then take this second answer and subtract this first answer. Right? If I took the area from 100 to 145, if I took this entire region here, and maybe I should switch colors. That's in red. And I subtracted out the area from 100 to 130. If I got rid of this green part of it here, start with red, get rid of green. Can you see how you're left with the blue? If you can see that, then if you can answer the green area and the red answer, you're done with this question. Well, the green area, I think we've already answered that. No, not quite. No, we did. 100 to 130, we did answer that. That's 47.5 for the same logic as we had up here. 130 is 2 standard deviations above the mean, so you're kind of using this 95% part. But I don't want 170 to 130, I only want 100 to 130, so you take that 95% and you cut it in half. The green shaded region here has an area of 47.5. That's this right here, 47.5%. What about 100 to 145? It's not 50%, not quite, because there are people with an IQ above 145, but damn near. 145 is 3 standard deviations above the mean, so I'm using this 99.7 rule. But I don't want to say it's 99.7%, it's just half of that because I'm only going to refer to half of the distribution. I take 99.7% and I cut it in half, maybe with the help of a calculator or something. You get 49.85%. That's 99.7 divided by 2. Gives you this. So the red region is 49.85. The green region is 47.5. If you subtract those two numbers, start with red, get rid of green, you'll be left with blue. Blue is the answer, IQ between 130 and 145. So 49.85 minus 47.5, maybe put that into a calculator. I think you'll get 2.3 0.35% as the answer to question 7. Lots of different difficulty levels. 1 and 2, fairly easy. 3, 4, and 5, they're starting to get pretty hard. 6 and 7, very hard. But you'll get a lot of practice with this. We'll practice these together. You know everything you need for the homework if you want to look at the homework now. I'm not saying you have to. We'll look at it together in class on Wednesday. But if you want to get some practice with this, you can. Now, disclaimer. Everything I've talked about so far is how you should do these problems. It'll benefit you the most in this class if you can do these empirical rule questions this way. The reason you learn the empirical rule is so that you can draw these pictures and understand this addition and subtraction and all these different ideas. That's how it'll benefit you in this class. But if I said that's the only way to answer these questions, I'd be lying to you. Right? This question that we got over here, what percentage of people have an IQ between 85 and 130? This shaded region. There's a much easier way. I don't know about much easier. There's an easier way to answer this question. I don't recommend doing it this way, but you can do it this way and get full credit. If I go back to my Google search for empirical rule, this picture that I put on that document, you'll note that there are lots of different pictures of the empirical rule, and here's one that might actually be more useful to you. Again, I don't want you to do it this way, but it's easier. And if you want to, I'll give you full credit. Instead of memorizing that 68% of observations lie within 1 standard deviation of the mean, and 95% of observations lie within 2 standard deviations of the mean, and 99.7% of observations lie within 3% of the mean, 3 standard deviations of the mean, sorry. You could memorize that this little region right here, you get 34% of observations. This turns out to be 13.5. This ends up being 2.35%. This ends up being 0.15%. How is that useful? Well, remember in this problem, what we're asked about is what percentage of people have an IQ between 1 standard deviation below the mean and 2 standard deviations above the mean. If I have all these numbers memorized, all I got to do is recognize that I'm talking about from this point up to this point, from here to here. So to figure out the total area, all I'd have to do is add together this number, and this number. 34 plus 34 plus 13.5 will give you 81.5%, and you'll get that answer. And you can use that method for any of these problems if you have all these numbers memorized, which frankly isn't that hard. You can memorize those numbers if you want. The only reason not to do it that way is easier. I'm not going to lie to you. The only reason not to do it that way is it won't be as beneficial for you to do it that way for the rest of this class. I promise. But can you get through this class doing it this way? Yeah. Can you use this on the quiz? Yeah, totally fine. Just, I want to be transparent about what will be the most useful to you. There's lots of different versions of this picture. You can find them if you just do a Google image search. I kind of like this one. It's sort of a cool picture. It's saying 68% of the observations are shaded in purple. And you get up to 95% if you include the green stuff as well. And then you get up to 99.7% if you include the orange stuff as well. And what that means is that this little orange slice here gives you 2.35% of observations. This green slice is 13.5% of observations. Note that this picture doesn't have, well, that's not what I wanted to do. The very little tails, maybe I can go back to this one. This 0.15%, it's not even labeled in this picture. So I guess I like this picture, but I wish they put 0.15% right here and 0.15% right here. That's the empirical rule. That's the end of this video. Sorry they're a little bit lengthy, but hopefully with them together, it was still shorter than class would have been today. Email me if you have any questions or anything you want to talk about between now and then. You could start this homework assignment if you want, but no real hurry. We'll catch up on everything on Wednesday.